The first topic that we will be looking at today will be number system. So number system, this is the basics of any other concept. So be it percentage, profit and loss or any other concept, the shortcuts, or in other words, number system is the most important topic. Most questions might not be asked from number system, but however, if you are good with number system, we can definitely say that you will be very good with calculations. And in number system, the first thing that we will be looking at in number system is classification of numbers. So when it comes to classification of numbers, so first our numbers can be classified as real numbers and complex numbers. So real numbers are numbers like 5, minus 5, 3.2, 3.33, etc. So the numbers may be either positive, negative or decimal numbers. It may be ending decimal or it may be never ending decimal. It may be 3.3 bar. The meaning of 3.3 bar is that it could be 3.33333 and so on without any ending. Complex numbers, by complex number I mean that it will have an imaginary part. So a number like 3i or 5 plus 2i. So this is called as complex numbers. From our recruitment exams point of view, the questions will be asked only from real numbers. We will never get any question from complex numbers. So we will just rule this off and we look at the classification of real numbers. So when it comes to classification of real numbers can be classified as into many ways, like integers, decimal numbers, so by integers it may be positive or negative integer. It could be plus 1, minus 10, 3. So this will be integers. Decimal numbers, it could be 2.5, minus 5.1 and etc. So these are called decimal numbers and these are called integers. The integers may be positive or negative, same way decimal numbers also might be positive or negative. Apart from this, there are other classifications that you should be knowing about. So the other classifications are rational numbers and irrational numbers. So what is a rational number? A rational number may be a positive or negative number. It could be represented in form of A by B. It could be represented in form of A by B. For example, if I take the number 10, this can be written as 10 by 1, A by B form. So I can say that 10 is a rational number. If I take the number minus 2.5, this can be written as minus 5 divided by 2, where A and B are integers. So minus 2.5 can be written as minus 5 by 2. Now I will give you a number 3.33. Is this rational or irrational? So most of us, what we will be thinking that this is irrational number. But however, this number 3.33, I can write it as 10 by 3. So 10 by 3 will be 3.33. It is rational number. So how will you identify rational number? So to identify rational number, you can look at this rule. So a number after the decimal point, it will have ending 2345. So 3.2345, the decimal ends, it is definitely a rational number. Or if it doesn't end, for example, a number like 3.33, I can represent this as 3.3 bar. So a rational number, it will be an integer or it will be a decimal number. If it is a decimal number, the number will end. At some point the number will end. Or if it doesn't end, there will be a pattern. For example, 3.3 bar, which means 3.3333 and so on. So 3.3333 and so on. So after the decimal point, 100th digit, 1000th digit, whichever digit they ask, I can tell that it is 3. So this way, if there is repetition after the decimal point, it is still rational number. So if there is repetition, I can definitely say that it can be represented in form of A by B. Let's take another number, 2.45 bar. This is still a rational number. Now some of you might be thinking, I have covered all the types of number here itself. Then what could possibly be irrational number? So by definition, an irrational number is a number that cannot be represented in form of A by B. So it cannot be represented in form of A by B. So some examples that we will be seeing here is a rational number, square root of 2. So square root of 2 will be 1.414 plus or minus 1.414 and so on. So there are n number of digits after the decimal point, never ending. At the same time, it cannot be represented in the form of A by B. Another example I can give is value of pi. or cube root of 10. So this way I can give n number of numbers. So mostly your irrational numbers will be either value of pi or square root, cube root or nth root of a number that is not a square number or nth power of a number. So these type of numbers are called irrational number. Now apart from this, what other classifications are there? The other classifications are quite simple. We can say that there will be natural numbers. Natural numbers. So natural numbers are positive numbers starting from 1. So 1, 2, 3, 4 and so on. N number of numbers. I can call it as natural numbers. Then whole numbers. Whole numbers are 0, 1, 2, 3, 4 and so on. So the whole numbers will start from 0, the natural numbers will start from 1. The next classification I can say is that even numbers and odd numbers. Even numbers will take the form of 2n, or in other words it will be divisible by 2. So 0, 2, 4, 6, 8 and so on. And odd numbers, they will take the form 2n plus or minus 1. So 2n plus 1 I will consider. So in this case it is 1, 3, 5, 7, 9 and so on. So these are called as odd numbers, these are even numbers. Now apart from this, there is one more important classification that you will all need to know. That will be prime numbers and composite numbers. Now what is a prime number? So a prime number will have only two factors. It could be divisible by only two numbers. For example, I will take the number 2. The number 2 is divisible by first table and second table, nothing else. So 2 has got only two factors, first table and second table. The number 3 is again a prime number, it can be divisible by 1 and 3 alone. Same way 5, 7, 11, 13 and so on. So these numbers are called as prime numbers. Now the next type of numbers will be composite numbers. Now what is a composite number? A composite number will have more than two factors. It can have 3 factors or more than 3. For example, I will take the number 4. The number 4 is divisible by first table, second table and fourth table. See, 1 4s are 4, 2 2s are 4, 4 1s are 4. So I can say that 4 is divisible by all these numbers. So 4 is a composite number. The number 6 is a composite number. It is divisible by 1, 2, 3 and 6. So 6 has got 4 factors. So 6 is again a composite number. So any number that has got more than 2 factors are called as composite number. Any number that has exactly 2 factors are called as prime numbers. Now in this classification, so when I am classifying it as prime and composite, there is one more special number that will appear. I hope everyone will know what is that number. The number is 1. So 1 does not fall under both these categories. Reason is, a prime number should have only 2 factors. Composite number should have more than 2 factors. But the number 1 has got only 1 factor, which is 1 itself. So 1 is a special number. It is neither prime nor composite. Now we will be continuing with the numbers topic, number system topic. The next concept that we will be looking at in number system topic is finding the number of factors. Finding the number of factors. So finding the number of factors. I already told you that a prime number will have exactly 2 factors. Composite number will have more than 2 factors. But how many factors? So to find that, we can be using this method. Now generally from in your interviews you will be getting questions like this. Find the number of factors for the number 300 or find the number of factors for the number 30,000. So this type of questions you will be getting, but how to solve them? So 30,000, if you see, it's a huge number. Finding the number of factors by calculating one by one seems impossible. So we will just see how to do that. So let's say I am asking a question, find the number of factors for the number 12. So you can write the number of factors for 12. So 1 into 12, 12. So first table I can divide. 2 into 6, 12. Second table I can divide. 3 into 4 is 12. Third table I can divide. 4 3s are 12. Fourth table I can divide. 5 into which number will give 12? Nothing. So fifth table I cannot divide. Next to 5 I can say that 6 2s are 12. So sixth table I can divide. After 6, 7 does not divide 12, 8 does not divide 12, 9 does not divide, 10 does not divide, 11 does not divide. The immediate number that divides 12 is 12 itself. So if you calculate, there are 1, 2, 3, 4, 5, 6 factors. So the number 12 has got 6 factors. The number 12 has got 6 factors. Now let's take a bigger number, a number bigger than 12. Let's take the number 36. So if I am trying to write the factors one by one, 36 is divisible by first table, second table, third table, fourth table, sixth table, ninth table. So when I am trying to write one by one like this, there is a possibility that I might miss out some number. So I will follow a small strategy in this case. So if I am writing one by one, I will miss out the number. So I will write it in pairs. So if I am writing 1 into which number will give me 36? 1 into 36. So 1 into 36 will give me 36. Next, second table, 2 into 18, 3 into 12. After 3, fourth table, 4 into 9. Fifth table, it does not divide. Next, sixth table, 6 into 6. After 6, seventh table, eighth table, ninth table, starting from 9. All the other numbers I have written here. So which means this number 36 has got 1, 2, 3, 4, 5, 6, 7, 8, and these both are same, 9. So this number 36 has got 9 factors. Now using the same method, we will try to find the number of factors for a bigger number. Let's say I will try to find the number of factors for 84. So I can write 84 as 1 into 84, 2 into 42, 3. Can I divide this by third table? Yes, I can definitely divide. So I can write this as 3 into 28, 4 into 21. Fifth table, I cannot divide this by fifth table. So I will write sixth table. Can I divide it by sixth table? So 6 into 14. So here this number 84 has got 1, 2, 3, 4, 5, 6. So 6 pair of factors. So every pair has 2 numbers. So 6 into 2, which gives 12 factors. This number 84 has got 12 factors. Now this method will work for smaller numbers. What if I give you a bigger number? Let's say there is an interview question that is like this. So find the number of factors of 12,000. So you will have to find the number of factors for this number 12,000. Now if you see 12,000, I can write it as 1 into 12,000, 2 into 6,000, 3 into 4,000, and so on. So if you are doing it in this method, in the entire exam, I think you can write this one question and come back. So definitely this method might not work for bigger numbers. So for bigger numbers, there will be a better method that you will be using, and I will be telling you that method. So the first thing that we will be doing to find the number of factors of any bigger number is factorizing that number. So we will see how to factorize that. So the number 12,000 I will be factorizing using prime numbers. So 12,000. So 12,000, can I directly divide it by 10th table? I can divide, but however in our method we will be using only prime numbers to factorize. I will not be using composite numbers, I will be using only prime numbers. So first thing, I will be dividing it by second table, 6,000. Again this number 6,000, I can again divide it by second table again. So divided by 2, 3,000, divided by 2, 1,500, divided by 2, 750, again divided by 2, this will give me 375. Now this number 375, I cannot divide it by second table. Can I divide it by any other number? So I can divide it by third table. Third table, 125. Next I can divide this again by fifth table, 25. Fifth table, 5. Now 5 is already a prime number, so I will stop my factorization here. Now the next step that I will need to do is, I have to write this as powers of these prime numbers. So this number 12,000, I can write it as 2 power some number into 3 power some number into 5 power some number. So 2 power 1, 2, 3, 4, 5. So there are 5 2's, so 2 power 5 into 3, there is only one 3. So 3 power 1 into 5, there is 1, 2, 3 5's. So there are 3 5's. So 2 power 5 into 3 power 1 into 5 cube. So once I factorize it like this, the next step that I will be doing to find the number of factors is increment the powers by 1. So what is the power of 2 here? 5. Now increment that 5 by 1. So 5 plus 1 will be 6. Next, 3 power 1, I will increment this by 1. 1 plus 1 will be 2. Next, the power of 5 is 3, I'll increment this as well by 1. I'll get 3 plus 1, 4. So now the total number of factors for this number, so 2 power 5 into 3 power 1 into 5 power 3, it will be given with 6 into 2 into 4. So 6 2s are 12, 12 4s are 48, which means the number 12,000 has got 48 factors. The number 12,000 has got 48 factors. So this will be the answer. Now we will try to do a similar question. We will try to do a similar question. Let's take the number 10,800. Now you will have to find the number of factors for 10,800. So for 2 minutes you can try by yourself, and if you are not getting the answer, you can follow the rest of the tutorial and find out what will be the answer. So now I will be giving you the explanation for how to find the number of factors for 10,800. So just similar to this 12,000, I will be doing prime factorization. So first I will divide this by second table, 5,400. Again second table, 2,700. Second table, 1,350. Again second table, 675. Next 675 I cannot further divide it by second table. So what I can try to do, I can try to divide this by third table. So in third table, 225. Now 225 again I can divide this by third table. Third table, 75. 75 I can again divide this by third table, 25. Now 25 further I cannot divide it by third table, but 25 I can divide it by fifth table. 5 is again a prime number, so I will be using 5 into 5. So as 5 is a prime number, I will stop with this. Now I will write this number 10,800 as 2 to the power 4 into 3 to the power 3 into 5 square. Right? Now I have made the factorization. What is the next step that you will do? You will increment the powers by 1. So 4 plus 1 becomes 5. 3 plus 1 becomes 4. 2 plus 1 becomes 3. So 5 into 4, 20. 20 into 3, 60. Which means this number 10,800 has got 60 factors. The next topic that we will be looking at right now is finding the HCF and LCM. So HCF and LCM of 2 or more numbers. So let's say I give you a number like 36. Can you find the HCF and LCM of 36? You cannot, because to find the HCF and LCM you will need at least a pair of numbers. You should need at least 2 numbers to find the HCF and LCM. Now first thing that we will be doing is I will try to find the HCF and LCM of the numbers 36 and 24. Now 36. First I will try to find the HCF. So what does HCF stand for? Highest common factor. So it is highest among the common factors. So to find the HCF, I will first need to know the factors of these numbers 36 and 24. So I will try to write the factors of 36. This number 36 is divisible by first table, it is divisible by second table, it is divisible by third table, fourth table, 4 9s are 36, fifth table I cannot divide, sixth table I can divide, 6 6 are 36, 7 I cannot divide, 8 I cannot divide, but ninth table, 9 4s are 36. Next 3 into 12, right, 12th table. Next 2 into 18, right, so 18th table, and 1 into 36, 36th table. So 36 has got 1, 2, 3, 4, 5, 6, 7, 8, 9 factors, as we already saw. Now I will try to find the factors for the number 24. So now this number 24 I can divide it by first table, second table, third table, fourth table, sixth table. You see 6 4s are 24. Next 3 into which number will give 24? 8. So 8 3s are 24. 2 into 12 will be 24. 2 into 12. 1 into 24 will again be 24. So these are the factors of 24 and these are the factors of 36. Now HCF. HCF is nothing but highest common factor. So these are the factors of 36 and these are the factors of 24. Now we will try to find what are the common factors of these two numbers. See, 1 is present here as well as here. So I can say common factor is 1. Again 2 is another common factor, 2. 3 is same way a common factor, 4 and 6. 1, 2, 3, 4 and 6. After 6, if you see 9, I don't have 9 there. 12. There is 12 here, which means 12 is again a common factor. 12. 18 is not there. 36 is not there. So now these two numbers have got 1, 2, 3, 4, 5, 6 common factors. Now HCF, what does this HCF stand for? Highest among the common factors. So among these common factors, which is the highest number? The highest number here is 12, which means 12 is the HCF. So your HCF will be 12. Now we will try to find the LCM. Now LCM is nothing but the lowest among the common multiples. So for HCF, I need to know the factors. For LCM, I need to know the multiples. So LCM stands for least common multiple. Least common multiple. Least common multiple or the lowest common multiple. Now I will try to find the multiples of 36. 36 into 1, 36. 36 into 2, 72. 36 into 3, 108. 36 into 4 will be 144. 36 into 5 will be 180. 216 and so on. You see, any number will have finite number of factors and infinite number of multiples. So you can multiply with any number and still go on till infinity. So the multiples of 36 are 36, 72, 108, 144, 180, 216 and so on. Same way I will try to write the multiples of the number 24. 24 ones are 24, 24 twos are 48, 24 threes are 72, 24 fours are 96, 24 fives are 120, 24 sixes are 144, 24 sevens are 168, and this way I can just go on. Now here I need to find the LCM. LCM is the lowest common multiple. So to know the LCM, I must first know the common multiples. So you see the multiples of 36. 36 is present here, but it is not present here. 72. 72 is present here as well as here. So 72 is a common multiple. So after 72, 108 is not present, but 144 is present in both the places. So 72, 144. The next number that will be present in both the places will be 216. So 24 into 9 you will be getting as 216. So 216. So this way you will get many common multiples. But we have to find the LCM. LCM is the lowest among the common multiple. So among all these numbers, which is the smallest? 72. So 72 will be your LCM. So here your HCF is 12 and your LCM is 72. However, we will not be using the same method to find. I just told you this method so that everyone would understand what is HCF and LCM. However, to find this HCF and LCM, we will be using a very simple method, which is L division. So here, if I need to find the HCF and LCM of 24 and 36, so I will be writing like this: 24, 36. So both these, is there any common number that will divide both these? Second table, third table, fourth table, any number you want, you can use. You can even use composite numbers. So here 24 and 36 both can be divisible by sixth table. So 6 4s are 24, 6 6 are 36. Next 4 and 6, can I divide both of them by any number? Yeah, I can divide both of them by the number 2. So I will divide them by 2, 2 times, 3 times. Now this number 2 and 3 does not have any common number. So I will stop with this. I will stop with this. Once I stop with this, my next step is to find out what is the HCF and what is the LCM. So to find the HCF, you multiply these two numbers, the numbers that is common for both. So if you multiply these two numbers alone, you will be getting the HCF. So your HCF will be 6 into 2, which is 12. So as we found here, we got the HCF as 12. Next, if we need to find the LCM, to find the LCM, I have to multiply all the numbers, including these two. So your LCM will be 6 into 2 into 2 into 3. So 6 into 2 into 2 into 3. So 6 2s are 12, 12 into 3 2s are 6. So 12 into 6 will give you the answer 72. So as we found the LCM there, we have found the same LCM 72 here. So this way you can find it easily using this L division method. Now what is the use of this HCF and LCM? We have been learning this HCF and LCM since our childhood, maybe like second or third class. However, from the interview point of view, you will be getting some questions based on HCF and LCM, based on some properties of HCF and LCM. So what are these properties? We will be having a look at them now. So now we will be looking at the properties of HCF and LCM. The first and foremost, the basic property of HCF and LCM. So if you find HCF and LCM of two numbers, if you find the HCF and LCM of two numbers, the product of HCF and the LCM will be same as the product of two numbers n1 and n2. Will be same as the product of the two numbers n1 and n2. We'll have a check whether this rule works everything or not. So I'll take two numbers 40 and 60. I'll take two numbers 40 and 60. I'll try to find the HCF and LCM. So I'll do the L division. Both these numbers are divisible by 10th table. So divided by 10 4 times, 6 times. Again divided by second table 2 times, 3 times. I can stop with this. Here you will get HCF as, so as I already told, the HCF will be product of the numbers in the sides alone. So 10 into 2, your HCF will be 20. Your LCM will be 10 into 2, 20, 20 into 2, 40, 40 into 3, 120. So your LCM here will be 120. So I found that the HCF and LCM of the two numbers are 20 and 120. Now I will apply this here. So I know HCF is 20, LCM is 120, and the two numbers n1 and n2 are 40 and 60. I will just check whether this rule works or not. So HCF 20 into 120 should be same as 40 into 60. Here it should be into. Now 20 into 120, so 0 0, 2 zeros, 2 into 12, 24. So 2400, left hand side I will be getting 2400, right hand side 0 0, 2 zeros, 6 4s are 24. Right hand side also I am getting 2400, which means I can definitely say that the product of the two numbers will be same as the product of their HCF and LCM. So based on this you might be getting some questions in your interviews, and I will be sharing one question like that. The question is, the HCF and LCM of two numbers are 48 and let's say 960. Let's say the question is like this: the HCF and LCM of two numbers are 48 and 960. If one of the numbers is is 240, then find the other number. You might be getting a question like this. So for a question like this, how we will be solving? So it is quite simple. I will directly use the formula. So what is the formula that I had told? I told you that the number 1 into number 2, this will be same as HCF into LCM. Now I know what is the number 1. Number 1 is 240 into number 2. This should be equal to HCF into LCM. The HCF is 48. 48 into LCM is 960. Now I will bring this 240 to the other side. So I will be getting number 2 will be equal to 48 into 960 divided by 240. Now 240, we already saw that 24 into 4 will be 96. So 0 0 I will cancel, 24 one time, 4 times. So I will get number 2 as 48 into 4. So the number 48 into 4 is nothing but 144. So this will be your number.